I welcome once again to all the participants of this program, which we are organizing mainly for our school teachers, with a idea that we would like to give you an overview that how the space technology is being used for the benefit of common man, as well as what are the recent advances which in my view, you must be aware so that you can also, kindle the excitement and curiosity of the young students in your schools whenever you are teaching them. So, in continuation of this series, today I'm going to talk, something about the geological, or you can say the landforms of different planetary bodies. Mainly, I will be focusing on our satellite moon and our nearest neighbor in terms of solar system, which is Mars. As basics of solar system and our planetary system was covered yesterday by Dr. Anil Bharadwaj, I will not go into details of that. I will quickly take you to some of these beautiful worlds, and when you go close to them, especially with the help of our satellite based observation capabilities, how does this world look like, how different they are with respect to our own planet, and how similar they are with respect to our planet. You will be getting an overview of especially for our moon as well as for the Martian surface, which has been most of the examples which I will be showing in this talk are mainly from our Indian exploration missions, namely Chandrayaan 1, Chandrayaan 2, and Mars Orbiter mission. So with these words and the background, let me go to the next slide. As you have been listening since last 2 days about the Indian space program and its vision, in the first talk, Director VSSC has given you a comprehensive idea about the various facets of Indian space program. I would only like to, just remind you that the Indian space program was started with the visionary efforts of Dr. Vikram Sarabhai, whose birth centenary we celebrated last year. And his vision was that a country like India, especially in those days, in late 60s and early 70s, we are still a developing country, but our economic situation was much, much weaker. At that juncture, he had the courage to tell to the countrymen and to the top management of the country, especially the government, that yes, the space technology can be of use, for the development and for the betterment and upliftment of lives of millions of Indians. And he started the Indian space program with a vision that we should be second to none in the applications of advanced technologies to the real problems of man and society. So today, with the help of state-of-art technology, with the help of industry, which was talked about, the role of industry was talked about with Dr. Somnath, with the help of academic institutions, in last more than 5 decades, Indian Space Research Organization has conceived a totally indigenous, what we call today as Atmanirbhar, Indian space program, which has different facets, which you learn about the space transportation, space infrastructure, space science program, and the applications of Earth observation and other communication and navigation satellite data for solving the problems of each one of us, and also making our life much more comfortable. Today, when you draw money from your ATM account, you may not realize that there is a reset sitting at the top of these ATMs, which is connected through satellite-based communication system. So this is how the seamless, use of space technology today. When you drive your car and when you navigate from your home to your office or to some other shops or to some complex or shopping mall, you use, the navigation technology, which takes you through a map, and you don't realize that all this information is basically having a connectivity with satellites which are orbiting, around the Earth and providing you the location-based services. So with these ideas which were conceptualized almost 4 or 5 decades back, today we are seeing the fruits of this Indian space program in terms of complete Atmanirbhar or indigenous efforts. Now, if we talk of our reach into the solar system, you must have heard that we have launched large number of space assets and satellites into what we call as the low Earth orbit, which is basically from 500 kilometer to 900 kilometer from the surface of Earth. We have also put large amount of satellite systems in what we call as the geostationary orbit, mainly to provide communication as well as meteorological services. We have also traveled a far off distance of around 385,000 kilometers from the surface of Earth, not only once but twice, in the form of putting two satellites, one, the Chandrayaan 1 in 2008 around the surface of Moon, and in 2019, when we returned to Moon with our next mission called Chandrayaan 2, we not only successfully put an orbiter around the Moon again, but we were also attempting to land onto the southern pole of the Moon, and we almost made it till our lander, which has reached as close as 200 meters to the Moon surface, finally did not soft landed at the Moon surface, and it basically toppled. So that has also given us a big amount of lessons. And then you also heard yesterday about the journey towards the Mars, which is around 200 to 225 million kilometers from the surface of Earth. And India became the first country in 2014 to successfully insert an object, man-made object, and which was known as MOM, or Mars Orbiter Mission, around the surface of Mars in the first attempt itself. So, as you can see, our presence, the presence of Indian-made objects is there, from almost, you can say, from 500 kilometers to all the way up to 225 million kilometers as we talk about the Indian space program. So this is basically, in one slide, I thought that I will tell you about the 50 years of journey of Indian space activity and the kind of space assets which we have created for various aspects in terms of using the space for applications, for deriving knowledge about planetary bodies, to provide communication services, or to provide the navigation services of the citizens of this country. Now, that was something about the space segment, which we call it the upward, linkages. Now, when you put a satellite into space, the satellite does certain functioning. If it is a communication satellite, it will have a transponder. If it is a remote sensing satellite, it will have camera systems. If it is a navigation satellite, there is an atomic clock, which keeps track of the ranging and the time of receiving and transmitting the signals from which you can accurately reconstruct your positions, or the exploration satellites, which have different type of sensors which can capture various amount of different type of data sets about those planetary objects. Now, all this data which is captured by the satellite systems has to be transmitted back to Earth, because we are the users. The humans are the users of this data. And today in our solar system, we are still searching for life in other planets or in other moons of different planets. And the big question is that, are we alone in the solar system or even in the universe? Because we have not come across, even though our civilization is one of the most intelligent civilization, what you can call. And today I can tell you that I have no hesitation in saying that we are living probably in the golden or platinum era of human civilization, where we have all kind of technology at our hand to solve various problems of humankind. But in spite of all this progress, we have not come across any other form of life other than planet Earth. So that's why on this planet, which is our home planet and which is also there in the solar system, we also put what we call as the ground segments, or antenna systems or communication systems which communicate with these satellites to receive these satellite data sets. And this is one example, especially in the context of planetary exploration, because We are sending satellites to far off places like Mars, moon of Earth. Then you also heard that we have a program, program is being planned to go to Venus. And then there is also a mission which is being planned in Lagrangian positions for studying the sun. So these far off objects, when they send the data, the distance is very large. You have to build large aperture antenna systems. So this is one of the such large aperture antenna system, which is part of what we call as the Indian Deep Space Network, IDSN. And all the data sets from which is acquired by these satellites over different planetary surfaces is transmitted back to such type of deep space network, which are located across the globe. So India also collaborate with NASA and with other space agencies, to acquire this data at their locations, and then later on this data is transmitted with the help of terrestrial communication network. So we have a beautiful Indian Deep Space Network, which is here in Bailalu in Bangalore. It is having a 32-kilometer antenna to receive signals from as far as places as like Mars, which is around 225 million kilometers away. And this is the control room, and there are a good amount of publications, and there's a book also on the story of Indian space deep space network, how it has been conceived, conceptualized, and how such kind of mega infrastructure has been developed in this country to communicate from far off objects. Now I'll come quickly to the topic of today's concern to each one of us. We will be initially talking about our own satellite, which is Moon. And this is a beautiful picture of Earth and Moon system. Moon is a part of the Earth system itself. It's not separate, and it is basically, what we can say is a kind of object which is umbilically tied to the Earth, and it goes around the Earth due to the gravitational influence both of Moon and Earth. Now, this picture tells you something very drastic. First of all, how the Moon goes around the Earth. Then it also shows you the backside of the Moon, because this photograph had been taken from a satellite which is operating from a distance which is basically more than the distance of Earth and Moon. So from that configuration, this image has been captured, and this image basically tells you two things. If you want to compare both Earth and its own natural satellite Moon, the diameter is almost roughly 1/3. Moon is almost 1/3 of Earth's diameter. Earth is having a tilt of around 23 degrees on its axis, but Moon does not have that much tilt. It is only tilted around 7 degrees. So there is no seasons. Seasonality is not there on the Moon. Earth has very comfortable temperature so that we all can live here comfortably. And as and when the temperature fluctuates to extremes, we also have developed now different mechanisms like heating and cooling mechanisms so that we can remain comfortable. But that comfort, if you are landing on the surface of Moon, you will not experience that, because during the daytime, the lunar day itself at a given location is equal to 15 Earth days. So if you are at a location on Moon, you will be receiving continuously for 15 Earth days the sunlight, and the temperature can go as high as 110 degrees or even much higher than that in degrees Celsius. And for the next 15 days at same location, there will not be any sunlight. So that's called the lunar night. And since you don't experience or don't receive the sunlight for next 15 days at that portion, the temperatures can plummet down to minus 180 degrees Celsius. So there are extreme temperature variability on the surface of Moon. We have this beautiful, thick, multi-layered atmospheric system which protects us from various harmful radiations and gases like, ultraviolet radiation, which is protected by ozone layer. Then there are other, like ionosphere, which protects us from the solar wind and solar plasma, and also provides mild greenhouse effect so that our temperature remains warm enough and we get comfortable surface temperatures on the surface of Earth. But on the Moon, its gravity is almost, very less, or 1/6 of the gravity of the Earth, and that with that gravitational attraction, Moon could not hold the atmosphere around it. And today we do not have any atmosphere. There are no gaseous molecules which are present on the surface of Moon. So basically, it's a body where the sunlight directly comes without any interference. There are no clouds, nothing, no winds, and that has its own hazard. That large amount of meteorites, which are basically there in our solar system, they keep on crashing onto the moon surface. One of the most important thing for survival on Earth is water, and in fact, they say that the life follows the water. Wherever there are big river systems, or on Earth, wherever there is a availability of water, you will see there is abundant life, both the human life as well as the animals, and even the biota, the plants. Like around the river basins, Amazon basin, around Ganga, most of the civilizations have thrived around river banks. But if you see, even on Earth, areas like Sahara or any other desert where there is a limitation of getting rainfall or less amount of water, you will see that life is not there. So the life is the water is the most important component for survival of life, and Earth has plenty of water. In fact, we have more than 75% of our surface covered by oceans, which are full of water, and there is a good amount of freshwater resources, even in terms of water in rivers, in reservoirs, in North Pole, South Pole, in solid ice form, as well as on Himalayan and other mountain range in the form of snow and glaciers. However, on Moon, yesterday the speaker told you that we found water on Moon, but that water is not sufficient enough for any kind of life support, and that water is there only in the molecular form, not even in the flowing or liquid or vapor or in solid form as we speak. Of course, there are publications now which tells us that probably there could be water ice on the polar regions of the Moon, and I will tell you certain examples of that also. But in general, the Moon surface is very dry, and whatever thin amount of or less amount of water is there present or has been detected by the newer experiments, it is also in the molecular form, and in terms of concentration, it is only in parts per million, not abundant water form. So these are the two typical characteristics of these two systems, which are very different, even though they are very close to each other. The distance of Earth to Moon is only around 185,000 kilometers. With a good solid rocket, with a powerful rocket, one can reach only in 2.5 days to Moon surface from Earth. And in fact, all of you may recall that during 1970 Cold War between USSR and Americas, they have landed, the astronauts on the Moon surface, and we had this Apollo mission, and you all may recall the Neil Armstrong, who became the first astronaut to land onto the surface of Moon. But apart from these three, those who were there in this Apollo mission, in total, I can tell you that 20 astronauts have visited the Moon surface, and large amount of Moon rock has been brought back to Earth for doing chemical composition analysis and to know the characteristics, composition of lunar rocks, and to understand more about the lunar geology. Now, if you see this picture, two pictures or two images, there are one on the left side and on the right side. These are the two hemispheres of Moon. This side, which is visible from the Earth, the other side or the back side of the Moon is never visible from the Earth. The simple reason is that Moon and Earth is tidally locked. The Moon takes same time to go around Earth and to rotate on its own axis. So that's why we are not able to see the far side or the back side of the Moon from the Earth. So to get an idea about the far side of the Moon, the only way is to go out of Earth or to send a satellite which can go around and which has some imaging cameras which can take pictures of the far side of the Moon. So these images has been compiled by millions of such images which has been collected by satellites, and a mosaic of these images has produced the true global map of the surface of Moon. Both this side we call as the near side, which we see from the Earth, and the other side which is called as the far side of the Moon. Now, two characteristics differences you will see in these two sides of the Moon. One noticeable thing is that you see two different kind of hues on this surface. One is the area which is very bright, Even if you see the moon by your naked eye, you will see brighter areas, and then of course there are very dark areas which are relatively, very smooth also. They are not having topographical variations as you have very high topographic variations on these brighter areas. Similarly, on the backside also you see large amount of brighter surfaces and very less amount of these dark surfaces. So these two surfaces has been given names by the geoscientists or geologists or lunar scientists. So the brighter surfaces are known as the highland regions. They are very high, topographically varying, very rugged, and they appear much brighter. Their rocks are basically reflecting large amount of sunlight, and these dark areas are called the lunar mares. Okay, and they are very dark. They absorb the sunlight, and the very less light is reflected from this mares. In fact, on the near side, you have large number of mares exposed, but on the far side, such dark surfaces are very less. This is also a question that why you have more mare systems on the near side and why less on the far side of the moon. Now, what is this mare means? Mare is a Latin word. Basically, this name was given by the earlier astronomers, those who were trying to look at moon with their primitive telescopes, and they found that these surfaces were very smooth, and they were basically were looking like basins, which from those telescopes they thought that has some water because they were very smooth. And in Latin, mare is known as oceans. So they have given this name. The Latin astronomers of those times, they called these surfaces as oceans. But later on, we found that there is no water. They are all rock forms only, and mostly they are basically the rocks which are commonly known as the volcanic rocks or basaltic rocks, which is made of the magma, which when it comes out due to the volcanic processes and cool down, it forms a rock called basalt. And these brighter areas are basically the rocks which are basically composed of lighter elements like calcium, aluminum, and silicate. Like the crust of the earth is also made of those elements, and they brightly reflect the solar light, and they are typically called the lunar highlands, or in geological parlance, I will not give you very difficult complex names. Geologists call them anorthosites. Okay, so the basic question, and one more thing which you will see, that the moon surface is having large amount of this, craters of varying size. It is simply because large amount of meteoritic showers. Since the formation of the solar system, large amount of activity in terms of meteorites, asteroids, collision has led to huge amount of meteoritic shower. And since the moon does not have atmosphere like Earth, many of these meteors, they burn out because of friction in the atmosphere. They simply come and collide and forms this type of impact craters. In fact, on Earth also you find impact craters. In India, we have impact craters at Ramgarh in Rajasthan. There is a famous Lonar crater lake in Maharashtra, and there are other famous craters, some Siberia in Africa as well as in America. But on Moon, both sides, you will find a large amount of craters of various magnitude and dimensions. So poetically, people say that they compare beautiful people, especially the ladies, with moon and call them Chandramukhi. But if you see the moon from very close, quarters, you will find so much of, undulations and these pits or craters that nobody would like to compare themselves with moon anymore. So this is the magic of space technology, that poets have to change their poetry. The science question is that how this moon has formed and what has been happening since the formation of moon. And today, as we live on the earth, our population is ever growing. Our demand for mineral resources is also growing. And the way population is growing, the projection is that maybe by the end of this century, we may need 1.5 Earth. Not one Earth may not be sufficient for our needs. So from where this half Earth will come? So now the scientists, technologists, and various countries are thinking that if they can send probes to moon and bring some lunar rocks back, then they can exploit these minerals which are present on the lunar surface, especially many of these rocks, which are basaltic rocks. They are rich in iron, nickel, cobalt, even titanium, and other minerals. And then probably now humans and big countries are thinking of exploiting lunar resources. So we have to also map that where are the different type of resources on moon, what kind of resources do exist. So all these scientific questions are deriving, today very ambitious programs by different countries for understanding various aspects of moon. In fact, China has a very extensive lunar program. Recently, they have sent a probe called Chang'e 5, which basically landed onto the moon surface and it collected lunar rocks and it flew back and brought a large amount of lunar rocks to the Earth. They have already demonstrated, of course, Americans have demonstrated these capabilities way back in 1970 itself. Russia had a very, very ambitious program to study moon, and Americans are thinking to go back to moon and put, human presence by Althemus program, NASA Althemus program, as early as by 2030 or so. India also has Chandrayaan 2, Chandrayaan 3, and then we are also collaborating, as has been told to you, with Japanese to put a lander and rover in the form of next Chandrayaan mission, which will be a joint mission with Japan. So these were some of the, the drivers for the lunar programs. And yesterday, my colleague, Dr. Anil Bharadwaj, he told you about the Chandrayaan 1 mission. I will not repeat this, but I will tell you that it was an international mission, and it had almost 11, instruments covering different part of electromagnetic spectrum. Now, all of you are aware, most of you are all science teachers, you are aware that the solar radiation, the sun which emits the radiation, it's not only the visible radiation which we see. The human eye is only susceptible or sensitive to the visible radiation, which is basically in terms of wavelength, we can say from 0.4 micron to 0.7 micron. But there is a large spectrum of energy which is emanated from the sun in the gamma ray, in X-ray, in ultraviolet, in infrared, far infrared, in microwave, and in terms of radio waves. So if we exploit all these wavelengths through the help of some sensors, specially designed sensors, we can get different facets and different type of information about the moon surface. So there was a high resolution camera to see the moon surface at 5 meters spatial resolution called terrain mapping camera. There were instruments which scientists call hyperspectral instrument, which captures reflected sunlight in different parts of electromagnetic spectrum, starting from visible to infrared. So using or analyzing this reflective pattern in different wavelengths, one can basically find out the composition or the rock types or mineral composition onto the moon surface. One can also find out the elemental abundance by the use of X-rays. Normally, the X-rays, which are brought by the sun's energy, they do get fluorescence. There is a fluorescence process happens, and this fluorescence, signal, when it gets reflected and recorded by a sensor, also provides you information about the elements which are present onto the moon surface. So one can do the elemental analysis and find out what kind of basic elements which you teach to students in your periodic table. Many of the elements which are found on Earth are also found on Moon, and people have made maps of these elements. So from these elements, the other compounds which we call minerals, they are formed, and from these compounds, the rocks are formed. So this is how, using different kind of instruments, one can reconstruct from the elemental abundance the rock composition of such planetary bodies. So three major scientific achievements of this mission, which lasted almost, for almost for 1.5 years or so, and collected large amount of data about the moon in, as I told you, in different part of electromagnetic spectrum, and more than hundreds of papers, scientific papers, were published by Indian scientists as well as American, European, Japanese, Chinese. So many people have worked on this data because this data was provided and made public to various set of lunar scientists. They analyzed, and then if I have to provide you a summary of all those observations, three characteristics, scientific findings were brought out from this analysis, which were previously not known about the moon. One is that that moon has a tenus. Tenus means weak, but active hydrosphere. All of you must be teaching about the hydrological cycle of Earth. When the water gets evaporated, it gets lifted into the atmosphere, it cools down, it condenses, and then cloud formation takes place. And when the saturation happens in the cloud because of the gravitational attraction, the large droplets are formed and rain happens. And with rain, this water comes back to the Earth's surface. Some goes down into the Earth crust in the form of groundwater. And then again, this cycle continues, which is known as the hydrological cycle on Earth. Similarly, there is an hydrosphere or a hydrological cycle, which is not as active what we see on Earth, but it is there. So people have made maps of the lunar water. Here in this image, you see this blue areas. They were mapped to have, the water in the concentration range of around, tens of ppm to thousands of ppm, not more than that, parts per million. So there is a weak, molecular water which was found with the help of Chandrayaan-1 data analysis, and we are extending this experiment on our Chandrayaan-2. I will show you some results of that as well. So the question was asked that how does this molecular water gets produced on the sun surface, and there are certain scientific hypotheses to explain, especially with the respect to the solar wind, which yesterday Dr. Haridwaj talked about, that when this solar wind, which is energetic particles, when they collide with the moon surface, then they are basically liberating the hydrogen and oxygen, and which is present in the minerals itself. And then by formation of these two molecules or two atoms, the hydroxyl OH and H2O do get formed, and it gets transported from hotter regions to the colder region of moon. So this basically forms what we call as the hydrosphere on the moon. So this was a major finding of Chandrayaan-1 mission, and many of you must have heard in newspapers and other journal magazines that India, along with American scientists, found water on the Earth for the first time. So this is what is the story of that finding. Another major important finding was that initially, the thought process about moon was that there is not much of activity in terms of geological movements onto the moon surface as we have in the case of Earth. You have landslides, you have volcanoes, you have earthquake taking place, and we have active plate tectonics, which basically causes these geological movements on the Earth's surface. So previously it was thought that it's not there on moon. Moon's internal heat has subsided very fast, and that's why we do not have much of volcanic or geological activity. But the high resolution data, I can show you this picture you may be seeing. There is a fault over here, and this fault was imaged with high resolution data sets, and such type of faults, if are present on any planetary surface, they are indication of subsurface geological activity. In fact, with the Apollo missions, the astronauts have left certain seismometers on the surface of moon, and they recorded what we have earthquakes. Similarly, they recorded extensive moonquakes, which basically gave an idea that internal dynamics is there on moon, which is basically causing moon surface to subside and earthquake activity to also occur onto the moon surface. Then the third and most important aspect in terms of how the moon was formed. So there is a hypothesis. Don't worry much about these technical words, ocean magma hypothesis or something. Basically, what it tells that if a body, planetary body, when it forms with a collision, it will be very warm. It will be molten or semi-molten. And with time, this heat will get dissipated. The body will start cooling. And as it cools, with respect to the typical gravitational law, the elements which are heavier in atomic mass, they will sink. So heavier atoms like iron, nickel, cobalt, magnesium, they will go down in this melt. And the lighter elements like silica, calcium, and other lighter elements, they will float. So when they will come to the top of this, solution as it solidifies. So basically, the upper part of the crust of any planetary body should be made of the lighter elements, and the interior should be made of heavier elements. And that process or that hypothesis was called lunar ocean magma hypothesis. And we found with the help of this spectrometers that indeed the lunar surface is made of these rocks, which are basically composed of lighter elements. And of course, at places where you have the heavier elements, they have come up due to the volcanic activity. So these three major findings were the crux of the Chandrayaan-1 mission, and became a very famous mission which changed our humans' understanding about the evolution, about the composition, as well as about availability of water onto the moon surface. So in nutshell, this is what the findings were. I will take you through some of these images which were basically analyzed to derive this understanding. But first and foremost, I will tell you about a very important process, which is called impact cratering process, and why so many impact craters are there moon, and how these impact craters becomes very important scientific sites for studying the composition, especially the interior composition of the moon. So this is a meteorite. Let's say if a cartoon, a meteorite is basically approaching the lunar surface, it will have first contact with the surface. As it collides, it will splash large amount of material. Then a transient cavity will be formed, and the material will be thrown out. You can do these experiments in your lab also, or some of you, if you have thrown a stone in pond, you will see that splashes. So similar type of splash of rocks will happen, and this is called ejecta. And within no minute, within few minutes or seconds, this type of deep impact craters will be formed if the impactor size is much larger. And if the impactor is much large, then you get this type of complex craters, which also will have a rebound from the surface and will have what we call as a predominant central peak. Basically, it happens because of Newton's law of action versus reaction. So in all craters, you will not find the craters which are smaller than 35 kilometers. Central peaks are not well developed, but in large craters on Moon or on Mars, you will find, or any other planetary body which is atmosphere or airless, you will find this type of central peaks. So this type of craters, they do get formed within no seconds because such type of meteoritic impacts happens. And of course, on Earth itself, large amount of meteoritic activity has happened. And today it has been proven conclusively that the dinosaurs, which were basically in the Jurassic era, they were dominating the Earth's surface in terms of organisms which were dominating the Earth, like the humans are dominating today. They vanished simply because of a meteoritic impact somewhere today where we have this Gulf of Mexico. And that impact was so huge that it changed the atmospheric composition and temperature regime of the Earth, and many of these creatures at that time could not survive. And so that's why the impact cratering and the impact cratering process in our neighborhood is a very, very important phenomena to learn that what these impacts can do to the surface and what will be their consequences. Now I show you a beautiful image which has been captured by our own Chandrayaan data sets or Chandrayaan imagers. And this image is basically of a crater which has been named on a name of a famous astronomer called Tycho, Brahmi Tycho, which was a French astronomer. And if you see Moon, on a full moon day or full moon situation, this crater you can see from your naked eye, or maybe if you take a good camera, maybe a zoom camera, 30x or 40x zoom digital camera, you can capture. So here in the southern portion, you will find this bright, crater over here, and with a beautifully developed ray system. So this crater, if we image from 50 kilometer or 100 kilometer distance from Moon, this is how it looks like. Such a beautiful crater, and this has a dimension of 85 kilometers. So from one flank to another flank, you have to travel 85 kilometers. It's a huge crater, and there is a beautiful central peak of this impact crater over here called Tycho's central peak, and this central peak has a height of around 2 kilometers or so. And these are the crater rims. So if you fall from here to this bottom, you will be falling roughly around 4 kilometers or so. And these are so-called terrace systems. These are typical staircases or steps. You can basically walk into the floor of this crater, Tycho crater, and this is basically the floor of the crater. So this type of craters you find on Earth also. As I told you, the famous crater in Maharashtra, in Buldana district, is typically of that. And on Earth, the difference is many of these craters, because we have rain and other things, they are now, most of them are filled by rainwater. But of course, on Moon, you don't have such luxury. So they are all dry and only are made of pulverized rocks, or rocks which basically got damaged because of such a large, massive hit. Now, this is another close, photograph, which was collected by our terrain mapping camera, which also incidentally has a capability to have three-dimensional imaging through photogrammetric, techniques. So don't worry about these words. it is as simple as understanding like we have all creatures have two eyes. Why the God has given us two eyes? We could have managed with one eye also. But to have the perception of depth, it is important to have two sensors separated by a distance so that one can have a depth perception. So similarly, if you put two sensors on a satellite separated by a distance, you can view the same area in different angles, and using some set of equations of mathematics, which is defined by a science called photogrammetry, you can reconstruct the height or the depth of that area. So using this type of techniques, we have also derived the what we call the elevation or digital elevation of moon. And today we know that at what height, at what location, what is the height of the surface at moon. So this is particular, central peak. Here the height is around 2 kilometers. This is the bottom. And then there are depressions. You can see the even landslide or sliding, rock flows. And then, of course, there are fractures on the surface of the moon also. So such kind of detailed maps are available today of the moon surface, which tells you that many of these landforms which you see, suppose if you visit, let's say Dehradun, you can also find such type of hills. Only difference will be these hills will have, the vegetation present on them. But since on moon there is no air, no water, no photosynthesis can happen, so they are all bare rock forms which are exposed to the solar wind or to the sunlight. This is another interesting kind of landforms you will find on moon. They are called impact melt. So what happens when these meteorites, they hit the rocks, basically, they produce so much of, from this potential energy, so much of kinetic energy is produced that at the location of impact, these rocks will start melting because of the friction and the energy which is brought by these meteorites. And when they start melting, they start flowing. So this is a kind of a rock flow which is basically now preserved. Of course, the moon has cooled down since the formation of these craters, but you can still see the wave or the wave pattern in this fluid material, which must be fluid at one time. But later on, with the reduction of temperature and cooling process, I told you the night temperatures are very low. All this material has become frozen in time, and this type of features or landforms on moon, they are called impact melts, and they are there everywhere wherever there are big impact craters. There are other kind of interesting features which look like snakes on moon. In fact, they are called riles. It's very sinusoidal features, and these are all depressions. If you look carefully, some of you may see it as an elevated stuff, but it is basically a depression. And people initially thought, the early astronomers thought that these are the rivers on the moon, the way we have this, sinusoidal, meandering river systems on Earth. So with those telescopes which are not having much resolving power, initial astronomer thought that these are the rivers which carry water on moon and canals, but nothing of that sort is there. Later on, with these high resolution images, we found that these are basically nothing but the lava tubes. Moon has an active volcanic activity, especially in these dark regions, which are called mare regions, and the lava used to flow because of this impact craters, the formation. And when this lava flows, it flows with the gravity gradients, and it makes this kind of sinusoidal features. And when the lava cools down, it also basically collapses, and this type of pits are formed. So these are all nowadays, they are called lava tubes, and many lava tubes have been found onto the moon surface. There is another interesting crater on the far side of the moon. It's called Slovinsky crater. Slovinsky was also a French astronomer. Most of these features on moon have been named on to honor various astronomers and important people on Earth. In fact, there is a Jawahar Sthal also is there, where the moon impact probe collided with moon. There is a Bhabha crater. Yesterday, I think Dr. Anil showed you the image of Bhabha. So some of the Indians also have been honored by putting these names of craters or certain landforms on moon. So this is a very interesting landform. This is also a crater, but you can see the characteristic difference, black and white together. And there is a central peak over here there also. This is basically, these craters are forming, they are very large craters. So when they collide, they basically puncture the upper crust of the moon. The crustal thickness can vary from few meters to tens of kilometers. So wherever there is a crust which is weak, they can puncture, and then below the crust there is magma, as you have in case of Earth. The mantle is there, mantle is full of magma, and then with this puncture, this magma gets, it oozes out, and with time it solidifies and creates and forms these volcanic rocks. Like in southern India, especially in Maharashtra, in Gujarat, you can find this black cotton soil, which is popularly, told to students, which is formed by weathering of volcanic rocks. So similar type of rock forms on Earth you can find, because active volcanism is still happening in Hawaii. If you go to Hawaii, when this lava comes out, the magma comes out, it forms lava, and then it meets, oceans or something like that. In Hawaii, it forms immediately a new surface, which will be very, very dark in color. So similar type of surfaces have also been formed onto the moon, and this is one such example which I showed you on the far side of the moon, called the Slovinsky crater. This is another interesting, three-dimensional image which we reconstructed from our Chandrayaan-1 mission. It's a crater called Theophilus crater, and you can see the beautiful, the terraces of this crater and the central peak. On this central peak, using our spectrometers, we found a new mineral. It is like basically this pink rubies which you find in on Earth, especially in Panna in Madhya Pradesh. So this type of minerals are also there at different locations, and different type of minerals do get formed because of different temperature pressure conditions. And impact craters becomes a very important site, because when an impact happens, a huge amount of pressure is imposed on the parent rock, and the temperature also becomes very high. So in that collision, new type of minerals do get formed, and at this location we found the presence of this, what we call as the new mineral, spinels. There can be different type of spinels in geological parlance: magnesium spinel, chromium spinel, but let's not go into that detail. This is about the spectrometer data. I will not tell you much more detail about it, but you can see on this axis is the wavelength, this axis is reflectance. So for this red curve, which is basically coming from magnesium spinels, the absorption of light is very, very different than the characteristic absorption from the moon surface, and that becomes the basis of identifying such type of new minerals on the moon surface. There are huge amount of large craters also there on moon. There are thousands of kilometer size. They are called multi-ring basins. So the one such crater is here in this lunar image called Mare Orientale, and this is more than 1,000 kilometer diameter. And then you can see different rings. There's an inner ring, there's a central ring, there is an outer ring, and then in between also, after this big crater was formed, later on small impacts were still happening. So you can see the secondary impacts are superimposed at different locations. So we had a big impact initially, and which was followed by the subsequent impact, and you can see all these secondary subsequent impacts later on by different size and different depths. So this type of beautiful multi-ring basins are also formed because of this impact cratering process onto the moon surface. Now, just to tell you some more details about the water story, because that's a very interesting story. Everybody wants to find water everywhere, because as I told you, water means life. So if you can find water, probably you find that around that area there will be probability of finding water. So on moon, large experiments have been conducted. There were rockets which were basically sent from Earth to puncture the north pole of the Earth, and then the plume basically which got generated by this particular mission was analyzed using spectrometers, and people found traces of ice in that. And there are basically these craters on the North Pole, Cabus, Amsterdam on the southern pole, Shackleton. They're all the primary targets for finding water in form of water ice on moon. Then, of course, this is spectroscopic observation of Chandrayaan-1. I told you about that. And now we are analyzing some of the new data from our Chandrayaan-2 sensor, which is also telling us a different story about the lunar water. So the basis of finding this lunar water with Chandrayaan-1 data was that we had this spectrometer. Remember that hyperspectral imager. So this was going up to 2,900 or up to 3,000 nanometers. This absorption or the reduction of reflectance or from the solar light at this wavelength is caused because of the presence of water. And we did find this absorption at the polar region. In equatorial region, these absorptions were not present, and that became the basis of this finding and this type of global maps were produced by our scientists. We also found that other than polar areas, at sporadic locations, there were traces of water. We term them as indigenous water. These are the papers published by me and my colleagues almost some 6-7 years back. And we also found water with the help of a mass spectrometer using this MIP probe, Moon Impact Probe, which basically were detached from Chandrayaan-1. And when it was approaching the moon, it started finding, the 18 AMU, mass, which is basically water mass around the surface of the moon. And this basically can be characterized as the first discovery of finding, water molecules on the surface, but very close to the lunar surface in that exosphere or Tennis atmosphere, which was also an Indian contribution. Recently, there were new analysis of these data sets, and people found direct evidences of ice in the polar regions of the moon. In fact, there are certain craters on the polar regions of moon where sunlight never reaches. They're called permanently shadowed areas. And in these permanently shadowed areas, you find probability of accumulation of water ice because they're very cold. Their temperature is around 70 Kelvin or 80 Kelvin or so. So in these traps, actually, sunlight never reaches, and there is no chance of this water getting or this ice getting, sublimated or vaporized. So from thousands and millions of years, it is assumed that the water ice is preserved. And some observations are suggesting that in few craters, there is water ice present on the north and the south pole of the moon. These are some other interesting morphological features or landforms. You see, this is a landform which is basically called the young volcano on moon. And it reminds you there are a lot of gaseous, small vesicles which are there at this location. You just compare this with when you boil milk, and when it is fully boiled, when you put off the flame, a kind of cream is deposited on the surface. We call in Hindi malai, and there will be small holes in that, simply because the gas which was trapped in the boiled milk, it escapes, and that process is basically forms a very rough or a very porous texture. So similar things happens when the trapped gases, they escape the lunar surface, they form this type of perforations, and this has been characterized as the young volcanic feature. There is a feature called INA, and there at multiple locations people have found such features. On different locations also they found these flow features which are supporting to be the very young volcanic landforms on moon, and that basically suggested that the moon is volcanically very active. There are boulder formations. There are many locations where the big boulders, like in Himalaya, you have boulder movements. When you go to hills, sometimes you will see that some boulders are coming down onto the street. So similarly on moon also boulder movement has been observed recently by very high resolution data sets. Similarly, there are fault systems. This is a lobate scarp or a fault on the moon surface. The fault length is around 100 meters or so. So many such observations are now conclusively proven that the moon surface is having some kind of dynamic component rather than being a dead surface completely. So with these are certain images and certain examples which I thought will kindle your curiosity and show you that how moon looks like when you see it from a very close distance, as close as 50 kilometers to 100 kilometers. You see, we are seeing this moon from Earth from a distance of around 185,000 kilometers, 185,000 kilometers. But when you go as close as 50 kilometers, 100 kilometers, that's how the moon looks like. There is a huge amount of data. We have produced atlases of that. If you simply do Chandrayaan-1 lunar atlas, you will find a PDF file and you can download it. You yourself can see it, show it to your kids, show it to relatives. It has many examples that how moon looks like, what kind of different landforms you find on moon. Now I'll tell you something about another interesting object in our solar system, which is our neighbor in terms of distance, which is known as Mars or Mangal in Hindi. So we had this Mars orbiter mission to understand more about this Mars. Yesterday, Dr. Bharadwaj has told various aspects about the mission, so I will not go into details. This is how the spacecrafts look like. This is the communication antenna system. And there were certain instruments on this spacecraft. So I will show you some of the data from this Mars color camera, which has taken beautiful images of Mars from varying distances. So this is a fantastic image, full disk image of Mars, which is known as the red planet. So definitely you can see it's not red, truly it's orangish in color. And then it also had shades of black and then shades of white in terms of Martian clouds. And on the polar top side, there is a polar ice cap. So large amount of ice is also there, like we have Arctic and Antarctic on Earth. So similarly, on Mars also, there is a northern polar cap, and then of course there is a southern polar cap also is present. And of course on Mars also you will find, these are the impact craters, which you can see yourself. There is large amount of dust in the Martian atmosphere. Mars has an atmosphere, which is very thin atmosphere, but it has an atmosphere around it, and other geological, features which are having different albedo or different color. So this is how the Mars looks like from a distance of roughly around 1 lakh kilometers or so from when our satellite was going around the Martian surface. Mars also has very big, other kind of landforms. This is a gorge. Gorge, you all may be aware that it's a narrow valley kind of thing. There is a famous valley in America, and this particular valley is called Valleys of Marineries. So you can see these are the two flanks of this valley. And then this width is around 200 kilometers, the depth is around 10 kilometers or so. And this valley is as long as around 4,000 kilometers. So such a huge, massive feature, which is known as Valleys of Marineries. And these are the depressions around these areas. They are cracks in the Martian surface. And this is a beautiful mosaic which we created of these Valleys of Marineries from our Mars orbiter datasets. This is the separate picture of same Valleys of Marineries, but it's a much higher resolution. So you can see the walls of this valley. And then, of course, it is also filled with large amount of dust at many occasions. So you can see the top layer is much clearer, and then you have this dust which is filling these Valleys of Marineries. Around this area, you also do see a large amount of impact craters on the surface of Mars also. So this is another area of around the Martian Valleys of Marineries. This is called Ophir Chasma. And here also you can see these. There are depressions, there are landslide deposits, there are mineral, which is basically iron dominated. That's why they look much black compared to the dust or the sand, which you will see on Earth also when you go to deserts or when you go to rivers. A similar kind of silica-rich dust is also present onto the Martian surface. The Mars also have very solid evidence that in geological past, Mars must be having liquid water because we do see all kind of evidences, of water, presence of water on Mars. Not today in the liquid form, but definitely in solid forms. We have this water ice and CO2 ice in the northern and the southern pole of Mars. So these are observations from an instrument called Mars Odyssey Gamma Ray Spectrometer, which tells you about basically the water presence or the hydrogen presence. So this is the broad hydrogen map. And then these are some of the satellite photographs of Martian surface, which shows you, some kind of erosion or the river, dried river channels. These are some kind of delta formations which you see on Earth. And then these are the pictures of the rovers. Mind you, there are multiple rovers which has been sent by Americans and recently by China also. So they have taken very close range photographs of Martian surface, and you can see boulders and pebbles. So these type of boulders and pebbles will be seen when you go to the, let's say, around Dehradun, in the rivers, you will find the small pebbles, boulders because of the water erosion, and at many locations in Himalayan river systems. So these are our indications that the water must have flown in these channels, and which has caused these erosions and rounding of these boulders. We also see, presence of gypsum veins, then presence of hematite balls onto the Mars from different observations, which are all indications. If you have hematite balls, it's an indication that oxidation process, basically, which happens in presence of water and hydrogen, oxygen, was predominant onto the Martian surface, and the formation of minerals like gypsum, etc., also do indicate that water must have remained present. Otherwise, this type of minerals cannot form onto the Martian surface. So, conclusively, today scientists have got evidences that Mars must have been a wet world once upon a time, but something has happened to Mars, which basically forced Mars to lose all its liquid water. We have to, there are certain theories for that, but today I will not go into those details, but definitely we can discuss it on some other day. So this is a mosaic which we created from our own data, Mars Orbiter mission data about the North Pole of the Mars. This is the ice, basically, ice, bright ice features. Some of them during winter will have surface dry ice because the Martian atmosphere is dominated by carbon dioxide. And in the cold temperature, this CO2 gets condensated and it starts depositing as over H2O ice as CO2 ice. This is a three-dimensional view of this. And similarly, similar features are found onto the southern hemisphere also. You look at these water channels, you see this a characteristic dried water channel. If you sometime travel to Rajasthan or Madhya Pradesh, you will find so many of these dried river channels. These are typically also present on Mars. You see this crater which has been cut across by this channel. These are all very clear-cut geomorphological or geographical, indicators or evidences that Mars must have been a wet surface once upon a time. Water would have been there. So if water would have been there, some kind of life would have also been there, maybe bacterial life or some kind of microorganisms must have been present, or their fossils must have been present onto the Martian surface. This is another regime or a region of Mars where you see the evidences of very extensive flooding. You yourself can see this area has small boulders, pebbles, and traces of water flow in an extreme situation. Another important thing about Mars that it has atmosphere, thin atmosphere, atmospheric pressure is very, very less, but it has atmospheric dynamics like the way we have Earth. There are also cloud systems which generates, but large amount of Martian atmosphere is dominated by dust, and Martian dust also controls a lot of surface processing. So this is a dust storm which we captured with our Mars color camera, and then you can see these are the twisters. In the summer also you will find dust twisters. If you go to Rajasthan, parts of Gujarat, which are very dry and hot, and similar type of twisters are also seen onto the Martian surface. You just see this area here on a day like October 20, 2014, we observed this dust storm or dust in the atmosphere, and after 8 days, the area was clear. So this shows you that the Martian atmosphere is also dynamic. With the winds blowing fast, large amount of surface dust goes into the atmosphere and slowly it subsides and the atmosphere becomes clear. So a lot of work is being done by scientists to understand the dust transport, characteristics of dust, and the electrical conductivity of these dust particles. Mars also do have, like Earth, the lightning events. So that also excites scientists. This is another beautiful photograph. These are big volcanic complexes on Mars. So this is the largest volcano in the solar system. It is called Olympus Mons. I will show you a detailed photograph of this. And there are 3 other volcanoes. They are much, much higher than the Mount Everest. They are in fact around 9 kilometers to 11 kilometers height. And the Mount, this Olympus Mons is 20 kilometers in altitude or in height. When you compare with Mount Everest, it is almost 3 times the height of Mount Everest. And since they are so huge and high, even in the thin atmosphere of Mars, at that height, the temperature reduces drastically, and whatever, water vapor or carbon dioxide which is present in the Martian atmosphere, in that temperature, it gets condensed, and you do see formation of water clouds around these peaks actually because of orography or because of altitudinal effects. This is a Another beautiful high-resolution photograph of this Olympus moon, which I told you is having a height of around 25 kilometers. And these are all formed because of volcanic eruptions. So this is the mouth of the old, volcano. They are dormant volcanoes. They are not active today. And you can see the photograph of this. And around the top of this, you will see this cloud is getting formed. And this is basically the deposition area of volcanic activity. So this is a beautiful photograph of the largest volcano in the solar system called Olympus Mons. We also analyzed some other data and found out albedo and something. We'll not go into details of this. I quickly come and close with Chandrayaan-2 yesterday. Dr. Anil has told you about details of it. Now these are some of the images coming from Chandrayaan-2 mission. And this is this big Oriental crater which has thrown a large amount of ejecta. So you can see this bullet-like patterns, very radially distributed, in one line, and they are called secondary craters. Because ejecta, when it is ejected, it follows certain patterns, and you can see these bullet type of patterns in one line, and they becomes what we call as a secondary crater. We are now analyzing this data, generating three-dimensional information on moon. You can see this 3D topographic variation of the moon surface, large amount of impact craters over here, and there's another beautiful impact crater. Now today we have such a resolving power that small bodies also we can see. You see this one boulder, a large amount of boulders sitting over here. Then they roll down, they go down here. You can see this boulder has fallen from here and went into the crater floor. And these boulder movements basically gives an idea that something keeps on happening. You can see these 3-4 boulders stuck up over here at this altitude. So it's an interesting world. Most of this data is available free of cost. One can download these images from internet. There are sources from where you can get data, Indian sources as well as international sources. This is an image of our new spectrometer, which is going up to 5 micron. And we are generating a lot of information about the water and the temperature of moon. You see, this is one image of the polar region of moon. And this characteristic absorption, which was not complete, or this total absorption feature was not available with M-Cube data. Today, we are in a position to characterize this feature in the form of this, hump. And this is because of the presence of water molecule at different locations. So at these locations, 1, 2, 3, I have marked over here. You can see there is a characteristic absorption at around 3 micron. And all these picture elements, which have these absorption lines, basically have presence of water. So now we are in a process of making a very advanced water map of the moon, and hopefully within 6 months to 1 year time frame, you will see many new scientific findings from our Chandrayaan-2 mission as well. This is our synthetic aperture radar mission data, which is a microwave satellite. It can penetrate into the moon surface, and this particular image is composed from the Chandrayaan-2 datasets. Now I'll close over here because time has already run out. What is follow-on? Anyway, I will not dwell yesterday. I think it was extensively discussed. Dr. Anil told that we are going to have a follow-on mission to Mars. We are also discussing, there is a concept study going on to go to Venus. We also talked about a mission to Sun. So there is a lot of excitement, especially for the young people in school and colleges, those who wants to understand the mysteries of our solar system and wants to know that what is happening in your neighborhood. If you want to learn about yourself, you can ask about your neighbors. Many times we don't know many things about ourselves, but if you go and talk to your neighbors, they may be knowing more about you. So this is also true in case of solar system. If we want to learn about what will happen to the Earth, look around, look at the Mars. Mars must have had water, but today it does not have water. So something has happened to Mars. Maybe whether those processes will happen on Earth also, we have to think about it. And whether the Earth also one day will become waterless as Mars has become, that's a big question. Similarly, there are totally different things are happening on Venus. Venus is of size of Earth, very close to Earth also. But if you look at the atmospheric composition, kind of, rock forms, kind of dense atmosphere it has, totally different. Similarly, Mercury is also a different world. And Jupiter and Saturn, they are totally different. Their density is also very less. So if we want to understand what is going to happen geologically to this beautiful planet Earth, definitely we have to look around us, look to our neighbors, at least in solar system, And of course, there are studies which are going on to understand different planets. Yesterday he told about exoplanets, which are part of the other solar systems. But definitely we have to know more about our own solar system. And if you look around that, you will also realize that the planet on which we are living, which we call as the Mother Earth, it's such a wonderful place. And humans, we have to teach to our children. Our generations have spoiled this earth in terms of, various issues, climate change, carbon emissions, etc., etc. But the future is in the hands of next generation. So they will understand and realize it more if they see neighborhood that there is no possibility of life. So we have to have our own survival on this only planet which is available to us. We cannot go anywhere. And so we have to protect our planet, such a beautiful planet which is known as Earth. And that message can be given to students by showing all these type of images which are coming from our neighborhood in the solar system. With this, I would like to thank each one of you. I will leave you with these photographs of a very interesting, volcanic feature on Mars. It looks like a kiwi or a penguin, with eye and beak. But mind you, it's not a penguin sitting on Mars. There is nothing like that. This is a volcanic complex which has basically have some kind of, tectonic activity. You can see the shift also, which has basically created this rupture over here. And these are the impact craters over this Mars. We have also compiled a huge amount of all these images in these book forms called the Mars Orbiter, Mars Atlas. Then there is a Lunar Science Atlas. They are all available in PDF form if you do Google, both in Hindi and English. And I hope that there will be very good resource books for yourself as well as for your students. With these words, I would like to thank each one of you. Thanks a lot.